Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle. The diameter of this semicircle is AB. We know that chord AD equals to 7 units, chord DC equals to 15 units, and chord CB also equals to 15 units, and we want to find out the size of AB, or the value of AB, that is the diameter of this semicircle. So first of all we will make a construction. We will join together points D and B by a straight line. Actually, the angle that was created here, angle ADB, a peripheral angle ADB, this angle equals to 90 degrees according to rule number 1 that states that a peripheral angle resting on the diameter of the circle is equal to 90 degrees. So I will read rule number 1 again. Rule number 1 states that a peripheral angle resting on the diameter of the circle is equal to 90 degrees. So actually, peripheral angle ADB rests on AB, that is the diameter of this semicircle. Therefore, according to rule number 1, peripheral angle ADB equals to 90 degrees. Okay, so peripheral angle ADB equals to 90 degrees according to rule number 1, because of the fact that it rests on the diameter of this semicircle, that is AB. Okay, so in the next step we will define the center of this semicircle as point O. Again, point O, this point is the center of this semicircle, and then we will join together points O and C by a straight line. And we will also join together points O and D by a straight line. And then we will focus on triangles OCD, the green triangle OCD, And we will also focus on the orange triangle, triangle OCB. Okay, so again we'll focus on triangle ODC, that is the green triangle, and triangle OCB, the orange triangle. So actually side DC of the green triangle equals to side CB of the orange triangle. Both those two sides are equal to 15 units. Okay, again, side DC of the green triangle is equal to side CB of the orange triangle. Both of those sides are equal to 15 units in size. And also OD is the radius of this semicircle because it starts from point O, that is the center of the semicircle, and ends at point D, that is the point on the semicircle itself. Therefore, it is the radius of this semicircle. I will mark the radius with the letter R, so OD equals to R. And OB is also the radius of this semicircle because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle. So OB or OD or DO, that is the radius of this semicircle, equals to OB, or side DO of the green triangle is equal to side OB of the orange triangle. Both those two sides are the radiuses of this semicircle, therefore they are equal to each other. Side DO of the green triangle equals to side OB of the orange triangle. And OC is a common side. It belongs both to the green triangle, and OC, side OC belongs also to the orange triangle. So OC equals to OC. It is a common side. So we actually proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we proved that the green triangle, triangle ODC, is congruent to the orange triangle, triangle OCB. Again, we proved that the green triangle, triangle ODC, is congruent to the orange triangle, triangle OCB, according to side rule. According to side rule. Okay, the green triangle is congruent to the orange triangle according to side rule. Actually, side rule states that if you prove that all the sides of one triangle are equal to all the sides of another triangle, then you actually proved that those two triangles congruent to each other. Those two triangles are congruent to each other. Okay? So from the fact that the green triangle is congruent to the orange triangle, we can deduce that angle OCD in the green triangle is equal to angle OCB in the orange triangle. So angle OCD in the green triangle is equal to angle OCB in the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. The green triangle is congruent to the orange triangle, therefore the corresponding angles, that is to say angle OCD and angle OCB, are also will be equal to each other as the corresponding angles in congruent triangles. And if we define angle OCD as alpha, then angle OCB also will be equal to alpha, because those two angles are equal to each other. Okay, so angle OCD equals to angle OCB, and both those two angles are equal to alpha, according to our definition. In the next step, we will focus on triangle DBC. This triangle DBC. So on triangle DBC, side DC of the triangle is equal to side CB. Actually, both those sides are equal to 15 units. Okay, so side DC in triangle DBC equals to side CB in triangle DBC, and both those two sides are equal to 15 units. And we have a rule, I will call it rule number 2. Rule number 2 states that in front of equal sides in the triangle, there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle, there are equal angles. So actually, in triangle DBC, we have two equal sides. Side DC equals to side CB. Therefore, according to rule number 2, in front of angle CB, we have this angle, and in front of angle DC, we have this angle. So according to rule number 2, those two angles that are located in front of equal sides are also equal between them. Therefore, angle CDB is equal to angle DBC, this angle, according to rule number 2. Okay, angle CDB equals to angle DBC according to rule number 2, because those two angles are located in front of equal sides. Therefore, according to rule number 2, they are also equal between them. So, and if we define angle BDC as theta, then angle DBC also will be equal to theta, because those two angles are equal to each other. So here, again, angle CDB equals to angle DBC, and those two angles are both equal to theta. Okay, in the next step we will define this point as point E, and we will focus on triangle CDE, the green triangle, and triangle CEB, the orange triangle. Okay, again, we will focus on the green triangle, triangle CDE, and the orange triangle, triangle CEB. So in those two triangles, side CD on the green triangle equals to side CB in the orange triangle. Both those two sides are equal to 15 units. Again, side CD in the green triangle equals to side CB in the orange triangle. Both those two sides are equal to 15 units. And also, we know that those two angles are equal to each other, so angle DCE in the green triangle is equal to angle ECB in the orange triangle, and both those two angles are equal to alpha. Okay, so side angle DCE in the green triangle is equal to angle ECB in the orange triangle, and both those two angles are equal to alpha. And also EC is a common side. It belongs to both triangle ECD, and it also belongs to the orange triangle, triangle ECB. So EC equals to EC. EC equals to EC, it is a common side. Again, EC equals to EC. It is a common side, it belongs to both triangles. Okay, so actually we proved that two sides and the included angle of the green triangle are equal to two sides and the included angle in the orange triangle. Therefore, we actually proved that the green triangle, triangle DCE, is congruent to the orange triangle, to triangle CEB. Again, we actually proved that the green triangle, triangle DCE, is congruent to the orange triangle, triangle CEB, according to side angle side rule. According to side angle side rule. Actually, side angle side rule states that if you prove that two sides and the angle included are equal to, if you prove that two sides and the angle included in one triangle is equal to two sides and the angle included of another triangle, then those two triangles congruent to each other. We proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, those two triangles are congruent to each other. Okay, so from the fact that those two triangles congruent to each other, we can conclude that angle DEC in the green triangle is equal to angle CEB in the orange triangle. Again, angle DEC, this angle in the green triangle, is equal to angle CEB in the orange triangle. So those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles are also equal to each other. Those corresponding angles are equal to each other because they are located in two congruent triangles. Okay, so if we define angle DEC as x, then angle CEB will also be equal to x because those two angles are equal to each other. So again, angle DEC is equal to angle CEB, and both those two angles are equal to x according to our definition. So actually, what is the size of angle DEC? X plus x actually equals to angle DEC. Angle DEB equals to x plus x. Okay, angle DEB, this angle is equal to x plus x in size. Angle DEB equals to x plus x, that is 2x. Okay, that is from one side, but actually we know that DB is a straight line. Chord DB is a straight line because we connected together points D and B by a straight line. Therefore, DB is a straight line. Okay, DB is a straight line. Okay, DB is a straight line, and we have a rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. Okay, the sum of the angles on a straight line is equal to 180 degrees. So I read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So actually, according to rule number 3, angle DEB, this angle equals to 180 degrees according to rule number 3 that states that the sum of the angles on a straight line equals to 180 degrees. So according to rule number 3, angle DEB equals to 180 degrees. That is from one side, but we have already found out that angle DEB equals to x plus x equals to 2x from the other side. Okay, angle DEB also equals to angle x plus angle x, that is 2x. So we found out that angle DEB equals to 2x and also equals to 180 degrees according to rule number 3. So from this equality we can conclude that we can derive that 2x equals to 180 degrees. 2x equals to 180 degrees, and if we divide this equality by 2 we will get that x equals to 90 degrees. Okay, so we found out that angle x equals to 90 degrees. So this angle x, is equals to 90 degrees. It is a right angle, so we will substitute angle x by 90 degrees. Also, this angle x equals to 90 degrees. Okay, so we have two angles that equal to 90 degrees. Angle CED equals to 90 degrees, and angle CEB also equals to 90 degrees. In the next step we will focus on line segment OC. OC is a straight line because of the fact that we connected points O and C by a straight line. Okay, and again we have rule number 3 that states that the sum of the angles on a straight line equals to 180 degrees. So the sum of those two angles equals to 180 degrees according to rule number 3. So if we focus on the left side of this straight line, according to rule number 3, the sum of the angles on these two angles on the straight line on these two angles will be equal to 180 degrees. So we have here two angles that according to rule number 3 they are equal in total to 180 degrees. And here we have angle BEC is a right angle, so it equals to 90 degrees, plus angle BEO will be equal to 180 degrees according to rule number 3 that states that the sum of the angles on a straight line equals to 180 degrees. So according to rule number 3, 90 degrees plus angle BEO equals to 180 degrees. Here we'll subtract 90 degrees from this equality, and we will get that angle BEO equals to 180 degrees minus 90 degrees is 90 degrees. So actually angle BEO is a right angle. Okay, angle BEO is a right angle. So this angle equals to 90 degrees. So we actually found out that around point E we have three right angles. Angle CED is equals to 90 degrees, angle CEB equals to 90 degrees, and angle BEO also equals to 90 degrees. So around point E, we have three right angles that the sum of them is 270 degrees. So I will read again the things that I wrote. Around point E we have three right angles that the sum of them is 270 degrees. We will define the size of the fourth angle, angle OED, as y. This angle equals to y in its size, and we have rule number 4 that states that the sum of the angles in any point is equal to 360 degrees. I will read rule number 4 again. Rule number 4 states that the sum of the angles around any point is equal to 360 degrees. Okay, the sum of the angles in any point is equal to 360 degrees. And especially at point E, the sum of the angles is 360 degrees according to rule number 3. So the sum of the three angles that is 270 degrees plus the size of the fourth angle that is y must be equal to 360 degrees according to rule number 4. Okay, again the sum of the angles of the three right angles around point E, that is 270 degrees, plus the size of the fourth angle must be equal to 360 degrees according to rule number 4. Here we can subtract 270 degrees from this equality, and we will get that angle Y equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that the size of angle Y is 90 degrees. It is a right angle. Angle Y is a right angle. So we actually found that all the angles around point E are right angles. Okay, it has 4 right angles. So in the next step, we will focus on the right triangle, triangle ADB. Triangle ADB is a right angle because angle ADB is a right angle, and we also focus on the right triangle, triangle OEB. Triangle OEB is a right triangle because angle OEB is a right angle. So I will draw those two triangles again. So I drew the two triangles again. The big triangle, triangle ADB, that is a right triangle, and the small triangle, triangle EOB, that is also right triangle. Actually, we have here those two angles are equal to each other. Both of those two angles are equal to 90 degrees, therefore they are equal to each other. So angle ADB in the big triangle is equal to angle OEB in the small triangle. Those two angles are equal to 90 degrees, and therefore they are equal to each other. And we also have angle B, that is a common angle. It belongs to the small triangle, triangle OEB, and angle B also belongs to the big triangle, triangle ADB. So angle B equals to angle B. It is actually a common angle because it belongs to both triangles. It's a common angle. And angle DAB in the big triangle also equals to angle EOB in the small triangle. Angle ADB, angle DAB in the big triangle equals to angle EOB in the small triangle, according to third angle theorem. Third angle theorem. Actually, third angle theorem states that if you have two triangles that has two equal angles, then the third pair of angles must be also equal in those triangles according to third angle theorem. Okay, again, if you have two triangles that has two equal angles, then the third pair of angles must be also equal in those two triangles according to third angle theorem, because the third angle actually completes the sum of the triangles angles to 180 degrees. There is a rule that states that the sum of the angles in any triangle equals to 180 degrees. Okay, so we actually proved that all the angles in the big triangle are equal to all the angles in the small triangle. Therefore, we actually proved that the big triangle ADB is similar to triangle EOB. Okay, we proved that the big triangle ADB is similar to the small triangle OEB, according to angle rule. Again, we proved that the big triangle ADB is similar to the small triangle OEB. Therefore, and they are similar to each other according to angle rule. We proved that all the angles in the big triangle are equal to all the angles in the small triangle. Therefore, those two triangles are similar to each other, according to angle rule. Okay, so from the fact that those two triangles are similar to each other, the following relationship exists between the sides of those two similar triangles. The relationship is that OB, the side of the small triangle, over AB, the side of the big triangle, equals to OE, the side of the small triangle, over AD, the side of the big triangle. Again, OB over AB equals to OE over AD. Okay, but what is OB? OB is the radius of the semicircle. It equals to R, and the size of AB is the diameter of the semicircle. Therefore, it equals to 2 times the radius, 2R. We also know that OA is the radius of the semicircle, so we can, even from this drawing, we can see that AB equals to R plus R, that is 2R. And anyway, the diameter of any circle is always equals to 2 times the radius. So AB is 2R equals to OE. And what is the size of AD? AD equals to 7 units according to what is given us in the question. So in total, we found that R over 2R equals to OE over 7. R over 2R is 1. So R is cancelled. So in total, we will get that 1 over 2 is equal to OE over 7. So here we will multiply this equality by 7 in order to get the value of OE. we will get that OE equals to 7 over 2 units. Okay, OE equals to 7 over 2 units. So we can write here that OE equal to 7 over 2 units. Okay. What is the size of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. So you can write down that EC equals to OC minus OE. Okay, EC equals to OC minus OE. But what is the value of OC? OC is the radius of this semicircle because it starts from the center of the semicircle, that is to say from point O, and ends at point C, that is a point on the semicircle itself. So OC is the radius of the semicircle, it equals to R. And what is the value of OE? OE equals to 7 over 2. We have already found out that OE equals to 7 over 2. So in total we found out that EC equals to R minus 7 over 2. Okay, we can write here EC equals to R minus 7 over 2 units. Okay, so in the next step we will focus on two right triangles. Actually, triangle EBC, this triangle is a right triangle because angle CEB is a right angle. So triangle EBC and triangle, this triangle OEB, triangle OEB is a right triangle because angle OEB is a right angle. So actually triangles EOB and triangle OEB are right triangles because they have one angle that equals to 90 degrees. So because of the fact that those two triangles are right triangles, we can implement the Pythagorean theorem in those two right triangles. According to the Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. So actually we will create the statement that EB square equals to EB square EB square equals to EB square. Actually, side EB is belong to both those two right triangles. Side EB belongs to the right triangle, triangle EBC, and side EB also belongs to the right triangle, triangle EOB. Okay, so we have this equality that EB square equals to EB square. So the first EB square will be related to this right triangle. Here EB square actually equals to OB square minus OE square. Again, in this right triangle, EB square equals to OB square minus OE square. Okay, here EB square equals to OB square minus OE square. In the second, EB square will be related to this right triangle. Here EB square equals to CB square minus EC square. It equals to CB square minus EC square. Okay, the second EB square relates to this right triangle, and in this right triangle EB square equals to CB square minus EC square. Again, EB square in this right triangle equals to CB square minus EC square. But what is the value of OB? OB is the radius, so OB square is R square minus OE square. OE equals to 7 over 2, so OE square is 7 over 2 square, that is 49 over 4, equals to CB square. CB equals to 15 units, so CB square is 15 square. 15 square is 225 minus EC square. EC equals to R minus 7 over 2, so EC square will be equal to R minus 7 over 2 square. R minus 7 over 2 square. So in total we got that R square minus 49 over 4 equals to 225 minus R minus 7 over 2 square. So we will open the brackets here, and we will get that R square minus 49 over 4 equals to 225 minus R minus 7 over 2 square equals to R square plus 7 over 2 square is 49 over 4 minus 2 times R times 7 over 2. Okay, so in total we got this equality. So here we will open the brackets. We will get that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4. Actually, here we have 2 over 2 is 1, so 2 is cancelled, and here we have 7R. Okay, so minus 7R is plus 7R. So in total we got this equality. Here we have minus 49 over 4 on this side of the equation, and here we have 49 over 4 in this side of the equality, and we have minus 49 over 4 on the other side of the equality. Again, here we have minus 49 over 4 on this side of the equality, and we have minus 49 over 4 on the other side of the equality, so we can cancel 49 over 4. So what is left after we cancelled 49 over 4 is R square equals to 225 minus R square plus 7R. So in this equality we will add R square to this equality, and we will get that R square plus R square is 2R square equals to 225 plus 7R. So here we will subtract 225 and also 7R from this equality. We will get that 2R square 2r squared minus 7r minus 225 equals to 0. So we got this quadratic equation: 2r squared minus 7r minus 225 equals to 0. The general equation for a quadratic equation is ax squared plus bx plus c equals to 0. This is the general equation for a quadratic equation, general formula for a quadratic equation, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we want to find out, and we will find out the value of x according to a special formula for x. X equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, so that is the solution for this quadratic equation. We have our specific quadratic equation that states that 2r squared minus 7r minus 225 equals to 0. So here the coefficients of this quadratic equation is a equals to 2, b equals to minus 7, and c equals to minus 225, and the variable of our quadratic equation is r, so x equals to r. Okay, so actually we will substitute the variables in the general quadratic equation in our specific variables, and we will find out the value of r. So here x equals to r, so r equals to minus b equals to minus 7, so minus b is minus 7, minus 7 is 7, plus minus root of b squared, b equals to minus 7, so b squared is minus 7 squared is 49, minus 4 times a, minus 4 times 2 is minus 8, times c is minus 225, over 2a, a equals to 2, so 2 times 2 is 4. So in total we got that r equals to 7 plus minus root of 49 times minus 8 times 225 minus 8 times 225 equals to 1800. So we write it down. So we got that r equals to 7 plus minus root of 49 plus 1800 over 4. So r equals to 7 plus minus the root of 49 plus 1800 is 1849 over 4. Okay, so r equals to 7 plus minus the root of 1849 is 43 over 4. So in total we got that r equals to 7 plus minus 43 over 4. So we have here two solutions. The first solution is R equals to 7 plus 43 over 4. 7 plus 43 is 50, and 50 over 4 is 12.5. So the first solution for R is that R equals to 12.5 units. And we have also the second solution. The second solution to this quadratic equation is R equals to 7 minus 43 over 4. 7 minus 7 minus 43 is minus 36 over 4. Minus 36 over 4 is minus 9. We got that R equals to minus 9. But R is the radius of the semicircle, and it is impossible that it will be equal to a negative number. So R cannot be equal to minus 9. It is a negative number. So this possibility is not correct. And we left only with the solution that R equals to 12.5 units. Therefore, the diameter of the semicircle equals to AB equals to 2 times the radius, that equals 2 times 12.5, that is actually 25 units. So we found out that the diameter of this semicircle AB equals to 25 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the size of AB, that is the diameter of this semicircle. We know that chord AD equals to 7 units, chord CD equals to 15 units, chord CB also equals to 15 units, and we want to find out the diameter AB, or the value of AB, that is the diameter of this semicircle. Okay, so in the first step we actually made a construction. We joined points B and D by a straight line, and there we created angle ADB. This angle is a peripheral angle, and it equals to 90 degrees according to rule number 1, that states that a peripheral angle resting on the diameter of the circle is equal to 90 degrees. So this peripheral angle, angle ADB, rests on the diameter of this semicircle, that is AB. AB is the diameter of the semicircle. So therefore, according to rule number 1, this angle, peripheral angle ADB, equals to 90 degrees. Okay, peripheral angle ADB equals to 90 degrees. Again, the peripheral angle ADB equals to 90 degrees according to rule number 1, because it rests on the diameter of this semicircle. Then we define the center of this semicircle as point O, and we join together points O and C by a straight line, and we also join together points O and D by a straight line. Actually, we created the green triangle and the orange triangle. In those two triangles, side TC of the green triangle equals to side CB of the orange triangle. Both those two sides are equal to 15 units, and also side OD of the green triangle equals to side OB of the orange triangle. Both those two sides are the radiuses of this semicircle, therefore they are equal to each other. So OD DO equals to OB equals to the radius of this semicircle, and also OC equals to OC. OC is the common side. It belongs both to the green triangle, and OC belongs also to the orange triangle. So OC equals to OC. And actually we proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, those two triangles are congruent to each other according to side rule. Okay? From the fact that those two triangles congruent to each other, we can deduce that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so angle OCD equals to angle OCB, and if we define one angle as alpha, then the other angle will be also equal to alpha. Okay, then we focused on triangle DCB, this triangle. In triangle DCB, side DC equals to side CB. Both those two sides are equal to 15 units. DC equals to CB equals to 15 units. And we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So in triangle DCB we have two sides that are equal to each other. Therefore, according to rule number 2, in front of side CB we have this angle, and in front of side CD we have this angle. So those two angles that are located in front of equal sides are also equal between them. That is to say, angle CDE equals to angle CBE. And if we define one angle as theta, then the other angle will be also equal to theta. Okay, so those two angles are equal to theta, so and angle CDB equals to angle DBC according to rule number 2. Then we define this point as point E, and then we focused on the green triangle, triangle CDE, and on the orange triangle, triangle CBE. In those two triangles, we have side CD that equals to side CB. Those two sides are equal, both those two sides are equal to 15 units. So side CD equals to side CB. Both those two sides are equal to 15 units. And those two angles are also equal to each other, both of them equal to alpha. So we have also angle DCE that equals to angle CBE, and both those two angles are equal to alpha. And EC equals to EC. EC is a common side. It belongs to both triangles, to triangle, the green triangle, triangle CED, and EC also belongs to the orange triangle, triangle CEB. So EC equals to EC, and we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we actually proved that triangle DCE is congruent to triangle CEB according to angle side rule. If you prove that two sides and the angle included in one triangle is equal to two sides and the angle included to the other triangle, then those two triangles congruent to each other according to angle side rule. Okay, so those two triangles congruent to each other according to angle side rule. From the fact that they congruent to each other according to angle side rule, we can conclude that those two angles are also equal to each other. And if we define one angle as x, then the other angle will be also equal to x. Okay, so angle DEC equals to angle CEB. Both those two angles are equal to x according to our definition. But what is the size of angle DEB? The size of angle DEB is x plus x. So angle DEB equals to 2x. That is from one side, but from the other side, DB is a straight line because we made the first construction in the beginning of the lecture. We combined points D and B by a straight line, therefore DB is a straight line. And because of the fact that DB is a straight line, angle DEB must be equal to 180 degrees according to rule number 3 that states that the sum of the angles along a straight line is equal to 180 degrees. We have the straight line DB, so this angle will be equal to 180 degrees according to rule number 3 that states that the sum of the angles along a straight line is equal to 180 degrees. So angle DEB also equals to 180 degrees according to rule number 3. Okay, so from one side angle DEB equals to x plus x, that is 2x, and from the other side angle DEB equals to 180 degrees according to rule number 3 that the sum of the angles on the straight line equals to 180 degrees. So we have this equality that states that angle DEB equals to 2x and also equals to 180 degrees. From this equality we can derive that 2x equals to 180 degrees, and if we divide this equality by 2 we will get that x equals to 90 degrees. So actually this angle that is x, it equals to 90 degrees, and this angle that is also x, it equals to 90 degrees. When we focus on CO is a straight line because we combined point C on O by a straight line. So CO is a straight line. But we have a rule that along a straight line, on the sum of the angles on the straight line equals to 180 degrees. So if we look on the left side of the straight line CO, the sum of the angles according to rule number 3 equals to 180 degrees. So we have here 90 degrees, this angle is 90 degrees, and this angle is angle OEB. According to rule number 3, 90 degrees plus angle OEB will be equal to 180 degrees. Okay, so 90 degrees plus angle BEO equals to 180 degrees according to rule number 3. Here we can subtract 90 degrees from this equality, and we got that angle BEO equals to 90 degrees. So this angle BEO equals to 90 degrees. So around point E we have three angles that are right angles, that the sum of them is 270 degrees. And if we define angle Y, and the fourth angle is angle Y, we have rule number 4 that states that the sum of the angles in any point, the sum of the angles around a straight line, the sum of the angles in any point, the sum of the angles around any point, the sum of the angles around any point. Rule number 4 states that the sum of the angles around any point is equal to 360 degrees. And especially around point E, the sum of the angles is equal to 360 degrees according to rule number 4. Okay, so we have already calculated that the sum of the three angles is around point E is 270 degrees, and we also have angle Y, so 270 degrees plus the size of the fourth angle y, must be equal to 360 degrees according to rule number 4. So we can subtract 270 degrees from this equality, and we get that y equals to 90 degrees. So we found out that the fourth angle is also a right angle, so all the angles around point E are right angles. Then we focused on triangles ADB and triangles EOB. I drew them again. Actually, those triangles are right triangles because they have angle of 90 degrees. So angle ADB equals to angle OED equals to 90 degrees. And angle B is a common angle because it belongs to the small triangle and also to the big triangle. Therefore, angle B equals to angle B. And the third pair of angles, angle DAB, must be also equal to angle EOB, according to third angle theorem, that states that if you have two triangles that has two equal angles, then the third pair of angles must be also equal between them, because it is complementary to 100 degrees in each triangle. Okay, so the third angle also equals in those two triangles. We actually proved that all the angles in the big triangle are equal to all the angles in the small triangle. Therefore, we proved that the big triangle ADB is similar to the small triangle OED according to angle rule. Therefore, from the fact that those two triangles are similar to each other, the following relationship exists between the sides of those two triangles, that OB over AB equals to OE over AD. Okay? OB over AB equals to OE over AD, but we know that OB equals to R, AB equals to 2R because it is the diameter of the semicircle. So OB equals to R, AB equals to 2R, and AD equals to 7 units. Okay, so we found that OE equals to 7 over 2 units, OE equals to 7 over 2 units, and actually EC equals to OC minus OE. That is to say, EC equals to R minus 7 over 2, and then we created the equality that states that EB square equals to EB square. We have here two right triangles, and side EB belongs to both right triangles, so we will operate the Pythagorean theorem twice. EB square will be related to this triangle, and so according to the Pythagorean theorem, in this right triangle, EB square equals to OB square minus OE square. EB square equals to OB square minus OE square, and the second EB square in this equality, the second EB square relates to this triangle, to this right triangle, and here EB square equals to CB square minus CE square. EB square equals to CB square minus EC square. And we know that OB is R, EO is 4 over 7, OE is 7 over 2, so OE square is 7 over 2 squared, that is 49 over 4. CB equals to 15 units, so CB square is 225, and CE equals to R minus 7 over 2, so CE square is R minus 7 over 2 square. We solved this simple equality. We found out, we arrived to a quadratic equation that 2R square minus 7R minus 225 equals to 0. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, c are the coefficients of this quadratic equation and x is the variable that we want to find out, and we will find out the value of x according to a special formula for x. In this special formula, a, b, c are the coefficients of this quadratic equation. X is the variable that we want to find out. So we found out the coefficients of our specific quadratic equation. A equals to 2, b equals to minus 7, c equals to minus 225, and x, and the variable of this quadratic equation is r, so x equals to r. So the only thing that is left is to substitute the variables in this quadratic equation by the variables that we found. We did this and we found out that the radius of the semicircle equals to 12.5 units. We have also the second solution that for the quadratic equation, that the radius equals to minus 9, but the radius cannot be a negative number. It must be a positive number, so this solution is cancelled, and we left only with the first solution that r equals to 12.5 units, and the diameter of any semicircle is 2 times the radius. It equals also to AB. AB equals to 2 times the radius, and the radius equals to 12.5 units, so 2 times 12.5 units equals to 25 units. So the radius of this semicircle is equal to 25 units. It is also equals to 2 times the radius of this semicircle. That is the diameter of this semicircle. The diameter of this semicircle equals to 25 units. Okay, thank you very much.